Welcome to section 2 of chapter 2, types of sets and the relationships between sets. In this session, we will continue our study of set theory by examining the different types of sets and the relationships that can exist between them. Understanding these concepts is essential because they provide the foundation for set operations, mathematical reasoning, and many applications in probability, statistics, and computer science. We begin by exploring the different types of sets based on the number of elements they contain. The first type is a finite set. A finite set contains a limited and countable number of elements. Since all its elements can be counted, the size of the set is fixed. For example, the set of vowels in English alphabet and the set of natural numbers from 1 to 10 are finite sets because they can specific numbers of elements, and we can list them. The second type is an infinite set. An infinite set contains an unlimited number of elements and therefore cannot be completely counted. Examples include the set of natural numbers, the set of integers, and the set of real numbers. No matter how many elements we count, there will always be additional elements remaining in the set. Another important type is the empty set, also called the null set. An empty set contains no element at all and is represented by the symbol of an empty set. For example, the set of human beings with 4 eyes is an empty set because no such members exist. Although it contains no elements, the empty set is still considered a valid set in mathematics. We also have a singleton set. A singleton set is a set that contains exactly one element. For example, a set containing only the number 6 is a singleton set. Even though it contains just one element, it is still treated as a complete set because if it has a single set and it is countable, it can be listed. Next, we will discuss relationship between sets. One important concept in cardinality, which refers to the number of distinct elements in a set. The cardinality of a set A is denoted by n of A or is in absolute value A. For example, if a set contains 5 elements, its cardinality is 5. Cardinality allows us to compare the size of different sets, which is equal with the number of elements. The most common relationship between sets is the subset relationship. A set A is called a subset of set B if every element of A is also an element of set B. In this case, we write A is a subset of B. For example, the set of odd natural number less than 10 is a subset of the set of natural number less than or equal to 10. In this case, the natural number less than 10 is a subset of a natural number less than or equal to 10. When one set contains all elements of another set, it is called superset. If it has additional element, at least one element more than the others. A special case of a subset is a proper subset. A set A is proper subset of set B, if every element of A belongs to set B, but B contains at least one additional element that is not found in A. In this case, B is the superset and A is a proper subset of B. This means the two sets cannot be equal because one set is strictly larger than the other. Another important concept is the universal set. The universal set contains all the elements under the considerations in a particular discussions or problems. It serves as the reference set from which other sets are formed and studied. The universal set is commonly denoted by the symbol U. Finally, we examine equal sets. Two sets are considered equal if they contain exactly the same element, regardless of the order in which those elements are listed. For example, the set 1, 3, 5, 7, 9 and 9, 7, 5, 3, 1 are equal because they contain the same members. In mathematics, the order of the element in a set does not affect the identity of the set. That's why the two sets are equal, regardless of the order. By the end of this session, you will be able to identify and distinguish between finite, infinite, empty, and singleton sets. Determine the cardinality of set. Explain subset and the proper subset relationships. Describe the role of the universal set and determine when two sets are equal. In the next session, we will explore operations on sets including union, intersection, difference, and the complement, and learn how these operations help us analyzing relationship among sets more effectively. See you in the next session.